Hello everyone, and let's have a quick look at this question. Okay, so you got a rectangular block B is at rest on a horizontal surface. Particle P is of mass 2.5 kg, and that, I'll just put that there, is of mass 2.5 kg, so the weight is 2.5 g, is placed on the upper surface of B. Particle P is attached to a light inextensible string which passes through a smooth poly, that one. Q has a mass of 3, so I'm going to say it's coming down 3g. Okay, and this is attached to the other end of the string, hangs freely below the pulley. Part of the string of P, part of the string between P and the pulley at the horizontal. Okay, so that's, and pulley is horizontal, so that part is horizontal, there's no indications of, so it's all taut. Particles are released from rest. Just going to put U there. The string taut. It is given that B remains in equilibrium while P moves up, moves on the upper surface of B. The tension in the string of P is 16.8. So I'm just going to read that bit again. The particle is released from rest. It is given that B remains in equilibrium, so the block remains in equilibrium. P moves on the upper surface of B, and the tension is 16.8. Okay, find the acceleration of Q while P and B are in contact. Okay, so this is going, the motion is going to be going down. That's being pulled by this tension, which is 16.8. and that will be falling freely, and what's holding it up is this tension 16.8. Okay, so the first part, A, is just going to be simply 3g minus the tension holding it up, 16.8, and that's going to equal mass times acceleration. That particle mass is 3 kg, so it's 3 times A. If we divide that through by 3, you'll get 3g minus 16.8 divided by 3. Just quickly grab my calculator. So that will give me 3 times 9.8, take away 16.8 over 3 equals 21 over 5. That's going to give me 4.2 meters per second. Okay, so that is the acceleration whilst that's in contact. Okay, now it says here determine the coefficient of friction between P and B. So this one, I've got this particle, I'm going to put the normal reaction force of that is R of P. So determine the coefficient of friction between those. Okay, so we know that, so I'm going to put along here is friction, and friction, as we know, is mu times the contact force. Okay, so in this case we know that the particle is moving with the acceleration, so that means we've got, and the motion is in this direction, so friction opposes that, so B is going to be 16.8, take away the friction, and that's going to equal the mass of that particle, which is 2.5, times the acceleration, which is going to be 4.2. So then I'm going to bring that to the other side and get the friction. Therefore friction is going to equal, quickly do that on my calculator, that will be 16.8 subtract 2.5 times 4.2, and that's going to give me 6.3. Now we know that R of P here is equals the weight, which is going down, so that's going to be 6.3 is going to equal mu times 2.5 G, since R of P, the reaction at P is going to be 2.5 G. So therefore, mu is going to be simply equal to 6.3 shared by 2.5 G. Do that on your calculator, divided by brackets 2.5 times 9.8. So you put brackets around it, and that will give you 9 over 35. I'll just call it 9 over 35 for now. Okay, if you want to put it as a decimal, just carry on, reduce to at least 3 single figures, 0.257. Okay, so that one's done. Happy with that. Now, it goes, given that the coefficient of friction between B, which is the block, and the horizontal surface, I'm assuming it's a table, is that, determine the least possible value of for the mass of B. Okay, so let's just quickly draw the block again. So what we got this time, and we got this P sat on top of it, and then we got this surface here. So here we've got this mass coming down, which is going to be 2.5 G, and we've got the weight of this block coming down on this table too, so that's going to be we don't know, but I'm going to call it mg. Okay, so that's coming down, so the reaction to that, I'm going to call that it's going to be reaction of B. That's the only force which is coming from this table, bouncing back because of those. Okay, so let's work that out. So basically we know that the at this table the friction friction at B on the table is going to equal to mu times R of B, and in this case R of B is equal to that plus that, so it's going to be 2.5 plus m report is multiplied by G. Okay, just factorize that, and we know that here mu, therefore friction, is going to be 5 over 49 multiplied by 2.5 plus mg. Okay, so that's my friction of B with the table. So now I'm just going to put different color. What's happening here? So what's happening here is this particle here is being pulled that way. Okay, but the contact of this particle P with this is only this friction which is going on there, which we calculated here. The friction is being pulled, so that particle there is being pulled with 6.3. okay, that as I said is pulling it from there, so that's the only thing. Not that we don't take into account the tension here, because that's just being pulled on the particle. This is the only thing which is in contact with the block. Therefore I really should yeah, that would be better if I really want to go for it. What I should say is this friction on the top of this block is 6.3, because that's the only thing that's in contact, that's dragging along there, and that friction, okay, which we got from here. Ignore that tension, that's got to do nothing. That tension's causing this friction as it's going along there. Okay, now to be honest with you, this friction, as you can see, is opposing it, so it's actually, so that tension is pulling that way, and the friction is opposing that, so that friction is going actually that way, so 6.3 is pulling it that way. So sorry about that, might as well, if I'm going to do it proper. Okay, so as that tension is pulling that, that friction is opposing that motion. So for this block to remain stationary, which it is, the friction on this one of the block in the table should be opposing it that way. Okay, so given that the coefficient of friction between B and the horizontal is that, determine the least possible. So we know that's staying stationary, so basically that is opposing that friction. So F of B is going to be greater than or equal to 6.3 in order to remain stationary. Okay, so let's just put a line here, work that out. So that is F of B, so we got 5 over 49 multiplied by 2.5 plus G is going to be greater than or equal to 6.3 for it to stay stationary. So let's times that up, so I'm going to just simply multiply the 49 up, then divide it by 5. Right, let's do that first. So we got 2.5 plus actually I'm going to take that G down, so I'm going to divide it by G, so we got it in that scenario. So let's just write that down. 6.3 times 49 over 5, in fact 5G, right, 5 times 9.8, so we get 6.3, and then we take that to the other side by subtracting it. So the mass of B has to be great, take away 2.5, we're going to end up with 3.8 kg. So it's going to be greater than that, so the least possible value of that is going to be, so the least possible mass of B is 3.8 kg. Okay, obviously it can be more than that because it won't shift, but it's got to be at least that for it to not move, for it to overcome this friction at the top, which is kind of pushing it that way. Okay, which is going in that direction to the left. This is good. Okay, hope that helps.